Hi dear friends, good morning to all. Myself Bhavsab Sonani, Assistant Professor, Department of Chemistry, Gokhale Education Society's Arts, Commerce and Science College, Jawad, District Palagar. Dear friends, in the previous part, we particularly have studied about the collision theory for biomolecular reaction and the unimolecular reaction. Particularly in the previous part of the video, we have studied in detail the collision theory for unimolecular reaction, which is applied by means of a scientist known as Lindemann, which is also called as the Lindemann theory for unimolecular reaction. Definitely in the previous part we also tried to derive the equation for rate of equation or rate of reaction on the basis of collision theory for biomolecular reaction as well as unimolecular reaction. Dear friends, today in this part of the video we are going to study about some advantages as well as disadvantages or drawbacks of collision theory, and how these drawbacks leads to the concept of activated complex, that is also called as the transition state. So today, dear friends, we are going to study about the disadvantages and the advantages of collision theory as well as the concept of activated complex, which is also called as a transition state, and it's very important during the formation of product from the reactor or during the conversion of reactant into the product. Dear friends, before discussing the concept of activated complex to the transition state, I would like to discuss different advantages of collision theory that we discussed in the previous part, because there are so many assumptions stated by means of collision theory in order to explain the rate of reaction or the rate equation for biomolecular reaction as well as unimolecular reaction. So based upon the same, we people are interested to know what are the advantages of this collision theory in order to study the rate of reaction in gaseous phase. So the first advantages of this collision theory is that the progress of simple molecular reaction in gaseous phase can understood very easily. Means whenever we want to study the progress of simple molecular reaction in gaseous phase, then this theory is very useful. Again, with the help of this collision theory, the calculated values of rate of equation or the rate equation or the rate of reaction in terms of rate equation are found to be same with the experimental values. It means that the calculated value and observed value are going to be same for the rate equation for simple biomolecular reaction. If these calculated values are compared with the experimental values of rate constant for biomolecular reaction, then the values are almost same. So this is a good thing with the help of collision theory. Again, this theory, collision theory, is a simple theory which can apply to provide easy calculations for the rate constant of the reaction and the reaction rate. It means that with the help of collision theory, it's very simple to apply this theory for the calculation of rate constant and rate of reactions, rate constant of the reaction as well as reaction rate for simple biomolecular reaction. Again, the another advantages of this collision theory for simple biomolecular reaction is that this theory explains the exponential increase in the rate of reaction with the help of or with increase in temperature. So how the rate of reaction increases exponentially with the increase in temperature, this is all about this all is explained by means of a collision theory very satisfactorily, that we discussed in the previous part of the videos during during the discussion of rate constant or the rate of reaction in simple biomolecular reaction. Dear friends, in addition to the advantages, there are some failures of the collision theory, which is also important to discuss here, which is also important to study here. There are some drawbacks or there are some limitations of this collision theory, and the first limitation of this collision theory is that this theory is only applicable to simple molecular reaction only in gaseous phase. It means that this collision theory can be applicable to only simple molecular reaction, and that molecular reaction should be also in the gaseous phase. It means that this theory is not applicable for the reaction that take place in liquid phase or that take place in solid phase. It means that the collision theory can be simply applicable to the reaction that take place in gaseous phase. Again, the another drawbacks or disadvantage of this of use of this collision theory is that the calculated values of rate constant are found to be same with the experimental value only for biomolecular reaction. It means that this is the good thing, that calculated values are same with the experimental value or the observed value, but this is observed only for biomolecular reaction. It means that any reaction other than simple biomolecular reaction will not satisfy this condition. It means that the calculated values of rate constant do not match with the experimental value or the observed value of rate constant for the reaction other than simple biomolecular reaction, means unimolecular reaction or the another type of the reaction, and for which if we will apply the collision theory, then definitely the calculated values will not be same with the observed value. Dear friends, another drawbacks of the use of this collision theory is that here this theory do not give any method to determine the steric factor, which is also called as the probability factor in the rate of reaction or in the equation of rate constant, because in the last part of the video we have seen that here in case of a biomolecular reaction some factor is included, that is called as steric factor, in order to get the correct equation to find out the rate of reaction. And this, how this steric factor can be calculated, how this factor should be calculated. So this collision theory does not define any method to calculate the steric factor, which is also called as the probability factor experimentally. The another drawbacks of this collision theory is that according to this theory only kinetic energy of the colliding molecule contribute to the energy required to overcome the energy barrier. Actually the energy which is required to overcome the energy barrier is called as the energy of activation. It means that according to the collision theory only kinetic energy is contributing in the energy of activation of the colliding molecule. It means that here the another type of the energies or are not considered in this contribution. Particularly these energies are rotational energy of the colliding molecule and the vibrational energy of the colliding molecule. So the contribution of rotational and the vibrational energies of the reactive molecule or the colliding molecule is not considered in the energy of activation. And again the important thing, as this theory explains that the rate of reaction means the reactant molecule get converted into product during the collision between them, or these collisions are responsible for the rate of reaction. But this theory does not explain anything about bond breaking and bond making process during the chemical reaction. So how the bonds are going to break, how the bonds are going to form in the product, this process is not explained by means of this theory. So dear friends, these were some drawbacks of this collision theory, which are very important or which are very essential to overcome by means of another theory, That's why the another theory came in order to discuss, in order to study here, or the another concept which can which can overcome the difficulties or the failure of the collision theory, and that we call as, or it is simply entitled as, activated complex. So this concept of activated complex is proposed by means of a different scientists who is known as Polanyi, Eyring, Pazer and Wigner. So this concept or this scientists have developed a theory based upon the fundamental properties like dimension and the masses of reactor molecules. So they try to define this concept in order to, or with the help of theory developed on the basis of fundamental properties like dimensions and the masses of the reactor molecule. This fundamental idea developed by this scientist is that initially the reactor molecule form an activated complex which is also called as the transition state, and then this activated complex or the transition state undergoes decomposition to form the product. It means that initially the reactor molecule will be converted into transition state or the activated molecule, and this activated molecule will undergo decomposition to form the product. Again, after this reactor molecule having sufficient energy must collide, and redistribution of energy and the valence bond must take place to form the activated molecule. It's very important. So this reactor molecules must having sufficient energy, and this sufficient energy in the sense energy of activation, they should collide with one another, and during the collision the redistribution of energy and the valence bond take place in order to form the activated complex. And this activated complex, it is the characteristic of the particular reaction. So activated complex will decide, or the energy of this activated complex, the stability of this activated complex will decide the overall rate of any chemical reaction. That's why each reaction has a characteristic activated complex. So here if we'll discuss about this, then you will come to know. So this diagram indicates how the reactor molecule get converted into product. Dear friends, see here it is also found that the rate of reaction is given by the rate of decomposition of the activated complex. If the rate of decomposition of the activated complex is more, then the rate of reaction will be also more. It means that rate of any chemical reaction is always depends upon the rate of decomposition of the activated complex or the transition state. And in activated complex theory, it is given that the energy of activation can be defined as simply the excess amount of energy which the reactor molecule must acquire to form an activated molecule. So this is the amount of energy that reactor molecule must acquire to get convert into activated complex or the transition state. That much energy is called as the energy of activation. See here, I would like to show here. Suppose this is a reactor molecule. So two molecules of HI, hydroiodic acid, they will acquire energy through the collision, and this will be converted into this state. This state is called as the activated complex, or it is also called as the transition state. And how much energy is required by this molecule to get convert into this complex, that much energy is called as the energy of activation. And that's why it is simply defined as this is the energy difference between activated complex or the transition state and reactor molecule. The energy difference between reactant and the transition state is called as energy of activation. Later this activated molecule or the transition state will undergo decomposition, and it will simply get converted into product, that is hydrogen, and another one is the iodine. Definitely here this is another reaction in which these two HBr molecule initially will acquire the energy, will be converted into transition state or the activated complex, and the energy difference between these transition state and the reactor molecule is called as energy of activation, and later this activated molecule will undergo decomposition to form the product, that is hydrogen as well as bromine molecule. So this is the way in which the reactor molecule get converted into product through the formation of activated molecule or the transition state. And the energy difference between reactant and the transition state is called as energy of activation. That's why it can be simply defined as the excess energy which is required by the reactor molecule to acquire transition state or the activated complex is called as energy of activation. Again, if you will compare the energy of transition state and the energy of activated molecules or activated complex, then you will come to that the energy of this activated molecules or the activated complex that we also call as a transition state is always greater than that of the reactant as well as product. Either in this reaction or in this reaction also, the energy of this transition state is always greater than that of energy of reactant as well as energy of product. Here it is the exothermic reaction, this is the endothermic reaction. That is not important here, but the internal energy of the activated complex is always greater than that of the either reactant or product molecule during the chemical reaction, and this activated molecule is always situated at the peak of the energy barrier, at the peak of this energy profile diagram, and this activated complex which is situated at this peak is simply having the highest energy than that of the reactant molecule as well as product molecule, and definitely this is the unstable intermediate during the conversion of reactant to product. That's why it suddenly undergoes decomposition to form the product. So this whole process is also called as a molecular activation, and definitely the concept of activated complex is very important because it decides the value of energy of activation, and the energy of activation will decide the value of rate of reaction. So dear friends, today I think you got a clear idea about the concept of activated complex with the help of this lecture. Before this, we also tried to study some drawbacks of collision theory, and these drawbacks is overcome by means of an activated complex theory or the concept of activated complex, which is very important in order to actually study the mechanism of bond breaking and bond making during the chemical reaction, which was one of the drawback of collision theory, which is not explained by means of a collision theory. So here, as this theory of activated complex or the concept of activated complex involves the study of transition state, it means it shows the path by which reactant molecule get converted into product through the transition state. It means that this concept is also able to explain the bond breaking and bond making process during the chemical reaction. So dear friends, I think you got a clear idea about the concept of activated complex, which decide the overall rate of reaction. So dear friends, in the next part of the video, we will discuss about, or we will study about how this activated molecules or the activated complex or the concept of activated complex is also related to thermodynamic in order to explain the rate of reaction. So here it is possible to explain the rate of reaction with the help of thermodynamic quantity also, thermodynamic parameter also. So that we will discuss in the next part of the video. So thanks again. So thank you all. Thank you very much.